Okay, well, at this time I would like to explore case number 2 where a is not equal to 1, where this leading coefficient of x squared is not equal to 1. And I'm going to show you 3 methods ultimately. Here's method number 1, which I call explore all the possibilities. Now, before we actually get into the particulars of that method, I just wanted to focus again on this general idea of how we end up with ax squared plus bx plus c when we're multiplying two binomials. We know that if we multiply the first two things here, we get the ax squared term. Okay? We also know that when we multiply the last two things, that's what gives us the c term. But how do we get the middle term, bx in particular? That comes from the sum of the products. Here's one of the products with this dashed line. Here's the other product with the other dashed line. And when we add those products together, we get the middle term. So when we explore all the possibilities, we are exploring the sum of products to try to get us this when we're looking at the factors of a and c. So let me give you an example to try to bring this home. Suppose we had 6x squared minus x minus 2. So because I have a coefficient here that is not equal to 1, 6 in this case, that means that the two things here could be maybe a 6x and a 1x, or maybe a 2x and a 3x. So I have a couple of options, and with those options I get actually more options altogether for how to add to that middle term than when the case was a equal to 1. So what I do in this case is I start to look at the factors of negative 2, just like we did before. This would be 1 times negative 2 or negative 1 times positive 2. But you also now need to consider the factors of the leading coefficient. So I can say this is 1 times 6 or 2 times 3. You could say negative 1 times negative 6 and negative 2 times negative 3. But let me save you some work. If you explore all the positive and negative options within one list of factors for either the constant term or the leading coefficient, then you don't need to do it for the other one. And you can take some time to prove that on your own just to see if it's true. But what I'm saying is that this is now sufficient to produce all the possibilities to try to come up with the two binomial factors. So let me list what these possibilities are. Abilities. Okay. And I'm also right next to that going to list what my middle term is, b. Okay. The middle term technically is bx. I'm just looking at this coefficient b. And in this case, b is equal to negative 1. And what I'm looking for, as indicated by these dashed lines, I'm looking for the sum of products of these lists of factors that gives me b equals negative 1. And here's how I do it. First, I'm going to start with 1 and 6 from the factors of the leading coefficient. And I'm somehow going to combine those with 1 and negative 2 from the factors of negative 2. And this is how I do it. First, I start with 1 times 1 plus 6 times negative 2. That's the sum of the products that I'm going to start with. 1 times 1 plus 6 times negative 2. 1 plus 6 times negative 2. And let's just see what that comes out with. Does that sum of products give me the middle coefficient that I'm looking for? This gives me 1 minus 12, which is negative 11. No, that doesn't work. So instead of 1 times 1 plus 6 times negative 2, I'm going to try 6 times 1 plus 1 times negative 2. 6 times 1 plus 1 times negative 2. That gives me 6 minus 2, which is 4. No, that's not it. I have now explored the two options that come from choosing the first pair of numbers here and the first pair of numbers here. So for my next set of possibilities, what I'm going to do, I'm still going to stick with the 1 and the 6, but I'm going to move down to the negative 1 and 2 here. Just like this. 1 times negative 1 plus 6 times 2. 1 times negative 1 plus 6 times 2, and that gives me negative 1 plus 12, which is 11. No, that doesn't work, so let me try that the other way around. Let me do 6 times negative 1 plus 1 times 2. Negative 1 plus 1 times 2, which gives me negative 6 plus 2, which is negative 4. I'm still not there yet. I still don't have negative 1 as the sum of the products. So I'm just going to keep going. Let's see how many possibilities. I've explored all the possibilities with 1 and 6, so I know for sure that I don't have 1x and 6x, okay, or the other way around. So I'm going to move on to the 2 and the 3, and I'm going to start with these two numbers here with factors of negative 2. So it's going to look like this: 2 times 1 plus 3 times negative 2. 2 times 1 plus 3 times negative 2, and that becomes 2 minus 6, which is negative 4. No, that doesn't work. What if I do it the other way around? What if I say 3 times 1 plus 2 times negative 2? 3 times 1 plus 2 times negative 2. This is looking promising. This gives me 3 minus 4, which is indeed negative 1. And I'm very happy now that I have found the correct combination that works, the correct sum of products that gives me b equal to negative 1. Let me just point out that there are a couple more possibilities, but once we've found what we're looking for, we can stop there. And this is what we're going to do with that combination, with the sum of the products. Let me just recopy it here. 3 times 1 plus 2 times negative 2. That's what gave us negative 1, this thing that we needed here. Notice that these numbers, the 3 and the 2, came directly from the factors of the leading coefficient. I do that on purpose. I write these in order, and I always write these numbers first. And the reason why I do that is because that tells me for sure these are my coefficients of x in the two binomials that I'm coming up with. Okay? So that gives me a 3x here, a 2x here. But now, be careful. Don't just drop that 1 down, because you have to ask yourself, how does 3 get multiplied by 1? Well, the 3 here in the 3x, that will never get multiplied by a term in the same binomial. Remember, when we multiply these binomials, we always do it into the other set of numbers. So the 3x is going to get multiplied by the 1 all the way over here. So this has to go into the opposite binomial. Same thing with the negative 2. In order to be multiplied by 2, it's got to go right there. And there are the two binomial factors. We can check that. 3x times 2x, that gives me the 6x squared. 3x times 1 gives me plus 3x. Minus 2 times 2x gives me negative 4x. And then negative 2 times 1 gives me a minus 2. Combine the like terms. That gives me 6x squared minus 1x, or simply minus x, minus 2. And indeed, that checks out. This method appears to work, although it might seem a bit arduous. Let me show a couple more examples of method number 1. And typically I do not write down this whole list. I just kind of float my fingers around until I find the right combination. So let me do that in a couple more examples. You determine for yourself if you like this method or if you prefer one of the other methods that I'm about to show you.